making fun of me.
Okay, so this is the calculator portion of the PreCalc partner test continued. We're on number 4. And we took the negative 543 degrees and we added 360 degrees. So we got that negative 183 was a coterminal angle. So our answer for number 4 is not A. If we add 360 to the negative 183, we're going to get 177. So B is also a coterminal angle, so it's not our answer. Now our last two answers are both negative, so that means we'll take our negative 543 degrees and subtract 360. And when we subtract 360, we get negative 903. So C is also a coterminal angle. So that means that D is not a coterminal angle of negative 543 degrees. Number 5, it wants you to find an angle in degrees and radians that is coterminal to negative 345 degrees, and it wants it between 0 and 2 pi. So it wants it within that first full circle or that first 360. So we'll take our negative 345 degrees, and to find a coterminal angle in degrees, again we'll add 360, and you're going to get a 15-degree angle. So that 15 degrees is within the first 360 degrees, so that one is good. And then we can take that 15 degrees and multiply by pi over 180. And this will give us our radian measure of that 15 degrees, which ends up being pi over 12. So our coterminal angle within the first rotation of a negative 345 degrees is pi over 12. On to the back with the story problems. Yes.
Okay. If I were to sum up anything about this back page, I think it would just be the ambiguity and then the issue trying to draw them, because I have to say it would probably be a lot easier, and these problems would be a lot easier if they were drawn up for me. And some of the vocab and like the wordiness messes me up. Just a thought. That's all I'm saying.
Okay. So for number 6, we're told that we have a 20-foot ladder leaning against a building and forming a 58-degree angle with the ground. The ladder begins to slide down the building, forming a 48-degree angle with the ground. We need to calculate how far the ladder slid down the building and how far the ladder was originally set from the building. So you should have 2 answers when we're done. So we have a building, and we have a 20-foot ladder leaning on this building, and we're given that this angle is 58 degrees. Then we're told, and this is a 20-foot ladder, so we know that that's 20 feet. And then we're told that the ladder begins to slide down the wall, or down the building, and it forms a 48-degree angle. So our ladder has now slid down the wall and is now in this position. So this angle is 48 degrees. And we still know that our ladder is 20 feet long. So that's still 20. Now we need to find how much it slid. So we need to find this x right here. That's what we're looking for, is how far it slid down. So to do that, we're going to find how high the ladder was originally. We'll call that y. And then we'll find out how far it was after it slid, which we'll call s. And we'll take the entire length of its original position, subtract the height once it slid, and we should get our x. So we know that originally we had a 58-degree angle for the entire thing. So we're looking for the opposite side, and we're given the hypotenuse. So we have opposite over hypotenuse, which is sine of that 58-degree angle, equals the y that we're looking for over 20. So you'll find sine of 58 in your calculator, multiply by 20, and you should get that y equals 16.96. Then we need to find s, so after the ladder has slid. So we know that our angle with the ground after the ladder has slid is a 48-degree angle. And again, we're looking for the opposite side, and we're given the hypotenuse. So again, we have sine of 48 now equals s over 20. So we're going to multiply the sine of 48 by 20, and you'll find that s equals 14.86. So now to find x, we're going to take y minus s, so x equals 16.96 minus 14.86, and we get 2.1. So that answers the first question. Calculate how far the ladder slid down the building. So the ladder slid down 2.1 feet.
Yeah,
Can you tell us, if you plug this into the calculator, you would have to put it in degree mode, right?
Yes, these are all in degrees.
So how would you type that into the calculator?
yeah.
So you're going to type in, for the first one, so for sine of 58, you're going to type in, you'll go to your trig functions, which are right underneath the control button, the yellow button on your calculator, and they'll all come up, and we're going to hit sine of 58, enter, so you get that decimal answer, and then you're going to multiply by 20, because you're solving for y. And that's how you get the 19.
Oh, okay. I just
Or
wanted to make
the-
sure.
Oh, I don't think mine's in degrees.
Oh.
Sorry. I apologize.
Sit upon the phone.
Throwing a fly.
Capitalize on my misfortune.
Is that a dog?
No, it's definitely, what kind of?
Okay, so sine of 58 times 20. So that's how you get the 16.96. And then the same thing for finding s. So that's how you get the 2.1 feet. So then we also need to find how far the ladder was originally set from the building. So we need to find that measurement. So we can use, again, our 58-degree angle. Now we're looking for the adjacent side, we'll call it h. And we're given the hypotenuse. So we're going to say cosine of the 58-degree angle equals h over the 20. And then when you solve for h, you should get that h equals 10.6. So it was originally set 10.6 feet from the wall. So your answer should be 2.1 feet and 10.6 feet.
Wait, one more time, how'd you get the H? So you got the, you have 58.
So you have your 58-degree angle, and you're looking for the adjacent side this time of the large triangle.
Okay.
So you're going to do adjacent over the hypotenuse. So that's the cosine,
Okay.
and you solve for h and you get 10.6. Number 7. Now I know number 7 confused a lot of you, so we're going to go over it. It says that a tower is located 42 meters from a tall tree. From the top of the tower, the angle of elevation to the top of the tree is 26 degrees. And the angle of depression to the base of the tree is 35 degrees. How tall to the nearest tenth of a meter is the tree? So we have our tower, and we know that we're measuring from the top of our tower. So the top of our tower is our horizontal. And we know that we have a tree. We have a tree that is 42 meters away from our tower. And we're told that the angle of elevation from the top of the tower to the top of the tree is 26 degrees. So if you know that the top of your tower is your horizontal, if you have an angle of elevation, you have an angle going above your horizontal. So the tree is taller than the tower. So you're going to have an angle of elevation. And this angle is your 26-degree angle. And then you're also told that you have an angle of depression that goes to the base of the tree. That's a 35-degree angle. So that's your angle of depression. It goes below the horizontal. And you're told that that is a 35-degree angle. And you're asked to find the nearest tenth of a meter, the height of the tree. So we have one right triangle and two right triangles. So this is going to be the x portion, this is going to be the y portion. You'll find both of these sides, add them together to give you the height of the tree. So we have an angle, we're looking for this side, and we know that our horizontal is also 42 meters. Because we know that the tree is 42 meters from the tower. So we have an opposite side and an adjacent side. So we're going to use tangent of our 26 degree angle. That equals x over 42. Solving for x, we'll get that x equals 20.5. And then we need to find y. So again, we have an opposite and an adjacent side. So we're going to have tangent of the 35-degree angle equals y over the 42. Again, solving for y, you get that y equals 29.4. So to find the total height of the tree, we're going to add 20.5 plus 29.4, and we're going to get 49.9 feet. So the tree is 49.9 feet. Number 8. Number 8 says 2 boats are observed from a lighthouse 55 meters above the surface of a lake. The angle of depression to the boat closest to the lighthouse is 63 degrees. The angle of depression to the second boat is 35 degrees. How far apart to the nearest tenth of a meter are the boats? So in problem 8, we're given that we have that the lighthouse is 55 meters above the water, or above the lake. And we're also told that there's an angle of depression, so our horizontal is the top of the lighthouse. We're told that we have an angle of depression to the boat closest, so that would be this boat in the picture. An angle of depression of 63 degrees. So this angle is 63 degrees. That whole angle, from the top to the second dotted line down, is 63 degrees.
It's the boat closest.
Closest to the lighthouse. So that boat is closest, right?
Oh, I thought it was just like the little angle from the inside, like
Here.
to the.
No, your angle of depression or elevation always goes from your horizontal.
Okay.
And then you're also told that there's an angle of depression to the second boat of 35 degrees. So this angle from your horizontal to your farther away boat is 35 degrees. And we're looking for how far apart the boats are. So we need to find this length. We need to find this length. And we need to find the total length. So we have two different triangles that we're looking at. We're looking at this triangle, and we're looking at this bigger triangle. So we'll label this smaller part X, and then the bigger part is Y. So given what we have, we know that this is a 90-degree angle here, from the horizontal back to the lighthouse. And we have 63 degrees of that accounted
So
for.
25.
So this is 27.
What?
So that's a 27-degree
Wait.
angle. 63
Oh,
minus
65.
90 minus 63
I wrote 65.
is 27.
That's why
So we know that that's a 27-degree angle. And we also know that this is a 90-degree angle from the lighthouse to the water. So to find this bottom angle, we subtract 90 minus the 27, which gives us a 63-degree angle again. And then we know we need to find this angle. So we know that from geometry, that if you have two parallel lines cut by a transversal, that opposite angles are equal. So you know that this is a 35-degree angle up here. So this is also a 35. So now, we can use this information to find our X and our Y. So, on the bigger triangle, so from the lighthouse to the farther away boat, finding that total length, we know an angle here, our 35-degree angle. We know our opposite side, and we're looking for our adjacent side. So we're going to use tangent of that 35-degree angle. That's going to equal the 55 over the y that we're looking for. Solving for y, you get 78.55.
Oh, got here.